Unit 9 Solutions Learning Objectives. After studying this lesson, you will be able to define solution, recognize the types of solutions, analyze the factors influencing solubility, explain the various modes of expression of concentration of solution, calculate the solubility of solutes in solvents. Introduction. Most of the substances that we encounter in our daily life are mixtures of two or more substances. The substance present in a mixture may exist in one or more physical state. For example, when we burn wood, the smoke released in mixture of solid carbon and gases like CO2, CO, etc. Consider the two mixtures, one which contains salt and water and another which contains sand and water. Water is one of the components in both the mixtures. In the first case, salt dissolves in water. In the second case, sand does not dissolve in water. Sand and water can be separated by filtration, but salt cannot be separated as it dissolves in water to form a homogeneous mixture. This kind of homogeneous mixture are termed as solutions. Solutions in day-to-day life. All the life forms on the earth are associated with solutions. Plants take solutions of nutrients for their growth from the soil. Most of the liquids found in human body, including blood and urine, are solutions. One of the naturally existing solution is seawater. The another one is air. It is a mixture of gases like hydrogen, oxygen, carbon dioxide and other gases. Day-to-day human activities like washing, cooking, cleaning and other few activities involve the formation of solutions with water. Similarly, the drinks we take in like fruit juice, tea, coffee, etc. are also solutions. A solution is a homogeneous mixture of two or more substances. Example, seawater. In a solution, the component is present in less amount by weight is called solute. The component is present in larger amount by weight is called solvent. In a solution, the component is present in lesser amount by weight is called solute. The component is present in a larger amount by weight is called solvent. Dissolution. The process of uniform distribution of solute into solvent is called dissolution. Binary solution. A solution must at least be consisting of two components, a solute, a solvent. Such solutions which are made up of one solute and one solvent with two components are called binary solution. Example, addition of copper sulfate crystals to water. Example, on adding copper sulfate crystals to water, it dissolves in water forming a solution of copper sulfate. One solute, copper sulfate, one solvent, water. Ternary solutions. The salt and sugar are added to water, both dissolve in water forming a solution. Here, two solutes are dissolved in one solvent. Such kind of solution which contain three components are called ternary solution. Types of solutions. Based on the physical state of the solute and the solvent, the substances normally exist in three physical states: solid, liquid and gas. Types of binary solutions. Solid solution. When solid is solute, solid is solvent. Example, copper dissolved in gold. Next, liquid is solute, solid is solvent. Example, mercury with sodium. Liquid solution. Solid is solute, liquid is solvent. Example, sodium chloride dissolved in water. Liquid is solute, liquid is solvent. Example, ethyl alcohol dissolved in water. Gas is solute, liquid is solvent. Example, carbon dioxide dissolved in water. Gaseous solution. Liquid is solute, gas is solvent. Example, water vapor and air. Gas is solute, gas is solvent. Example, mixture of helium oxygen gases. Based on the type of solvent, most of the substances are soluble in water, so water is called as universal solvent. The basis of type of solvent solution are classified into two types. They are aqueous solutions and non-aqueous solutions. Aqueous solution. The solution in which water acts as a solvent is called aqueous solution. In general, ionic compounds are soluble in water and form aqueous solution more readily than covalent compounds. Example, common salt in water, sugar in water, copper sulfate in water, etc. Non-aqueous solution. The solution in which any liquid other than water acts as a solvent is called non-aqueous solution. Solvent other than water is referred to as non-aqueous solvent. Alcohols, benzene, ethers, carbon disulfide, acetone are used as non-aqueous solvents. Example, sulfur dissolved in carbon disulfide, iodine dissolved in carbon tetrachloride. Based on the amount of solute in the given amount of solvent, solutions are classified into the following types. 1. Saturated solution. 2. Unsaturated solution. 3. Supersaturated solution. Saturated solution. A solution in which no more solute can be dissolved in a definite amount of solvent at a given temperature is called saturated solution. Example, 36 gram of sodium chloride in 100 gram of water at 25 degrees Celsius forms saturated solution. Further addition of sodium chloride leave it undissolved. Unsaturated solution. Unsaturated solution is one that contains less solute than that of the saturated solution at a given temperature. Example, 10 gram or 20 gram or 30 gram of sodium chloride in 100 gram of water at 25 degrees Celsius forms an unsaturated solution. Supersaturated solution. Supersaturated solution is one that contains more solute than the saturated solution at a given temperature. Example, 40 gram of sodium chloride in 100 gram of water at 25 degrees Celsius forms supersaturated solution. This state can be achieved by altering any other conditions like temperature, pressure. Supersaturated solutions are unstable and the solute is reappearing as crystals when the solution is disturbed. Concentrated and dilute solutions. When we compare two same solute and solvent in a solution, the one which contains higher amount of solute as per the given amount of solvent is said to be concentrated solutions, and the another is said to be dilute solution. Differentiating solutions as dilute and concentrated is a qualitative representation. This difference is observed by means of some physical characteristics such as color, density, etc. Solubility. Solubility is defined as the number of grams of a solute that can be dissolved in 100 gram of solvent to form its saturated solution at a given temperature or pressure. For example, 36 gram of sodium chloride need to be dissolved in 100 gram of water to form its saturated solution at 25 degrees Celsius. Factors affecting solubility. There are three main factors which govern the solubility of a solute. They are 1. Nature of the solute and solvent. 2. Temperature. 3. Pressure. Nature of the solute and solvent. Predicting solubility is like dissolves like. This expression means that dissolving occurs when similarities exist between the solvent and the solute. Example, common salt is polar compound and dissolves readily in polar solvent like water. Non-polar compounds are soluble in non-polar solvents. Example, fat dissolved in ether. But non-polar compounds do not dissolve in polar solvents. Polar compounds do not dissolve in non-polar solvents. Effect of temperature solubility of solid in liquid. Solubility of solid solute in a liquid solvent increases with increase in temperature. For example, a greater amount of sugar will dissolve in warm water than in cool water. In endothermic process, solubility increases with increase in temperature. In exothermic process, solubility decreases with increase in temperature. Effect of temperature solubility of gases in liquid. The water bubbles when it is boiled because solubility of gas in liquid decrease with increase in temperature. Generally, water contains dissolved oxygen. When water is boiled, the solubility of oxygen in water decreases, so oxygen escapes in the form of bubbles. Aquatic animals live more in colder region because more amounts of dissolved oxygen is present in water of cold regions. Effect of pressure. Effect of pressure is observed only in the case of solubility of a gas in a liquid. When the pressure is increased, the solubility of a gas in liquid increases. Example, solubility of gases in liquids are carbonated beverages, that is, soft drinks, household cleaners containing aqueous solution of ammonia, formalin aqueous solution of formaldehyde, etc. Thank you. You can watch the continuation of solutions in the next video.